A new Earth-observing mission launches to space, a move to make more room aboard the space station, and some valuable space station science returns to Earth. A few of the stories to tell you about this week at NASA.
And liftoff. Liftoff of an Atlas V rocket and Landsat 9.
On September 27th, our Landsat 9 satellite launched from Vandenberg Space Force Base in California. This joint mission with the U.S. Geological Survey will capture images of Earth from space that will be added to the nearly 50 years of freely available Landsat data researchers and officials use to monitor the health of Earth and manage essential resources. Learn more at nasa.gov/Landsat9. On September 28th, aboard the International Space Station, 3 crew members, including our Mark Vande Hei, relocated their Soyuz spacecraft from the station's Rosvet module to the brand-new Nauka multipurpose laboratory module. It is the first time a spacecraft has docked to Nauka. The move also frees up Rosvet for the October 5th arrival of another Soyuz spacecraft. A SpaceX Dragon cargo resupply spacecraft left the space station on September 30th to return more than 4,600 pounds of supplies and valuable science to Earth. The experiments include research on neurodegenerative diseases such as Alzheimer's, a study that could help treat muscle atrophy in elderly people on Earth, and more. This was SpaceX's 23rd commercial resupply services mission for NASA. On September 30th, engineers at our Stennis Space Center conducted a hot fire test of an RS-25 engine on the center's A1 test stand. This was the 7th and final planned test of the current test series to support development and production of the engine for our Space Launch System rocket. 4 RS-25s will help power the SLS on future moon missions, including Artemis 1 targeted for later this year. For more details, visit nasa.gov/SLS. For the next few weeks, we will be mostly incommunicado with our fleet of spacecraft on and around Mars. This communications timeout happens about every 2 years during Mars solar conjunction, when Earth and Mars are on opposite sides of the Sun and can't see each other. Sending radio signal commands to spacecraft during this time is risky because solar activity can corrupt those commands and cause unexpected behavior. Researchers using data from our Hubble Space Telescope have determined that the wind speeds just inside the boundary of Jupiter's Great Red Spot are accelerating. Their research shows that the average wind speed in this region of the storm increased by up to 8% from 2009 to 2020. The massive storm spins counterclockwise at more than 400 miles per hour, and the vortex is bigger than Earth itself. NASA has transferred findings from the agency's Airspace Technology Demonstration 2 or ATD-2 project to the Federal Aviation Administration for nationwide implementation. Over the past 6 years, the project demonstrated this suite of airport operations tools at several U.S. airports to save fuel, reduce carbon emissions, and increase information sharing between the FAA and industry. Find out more at nasa.gov/aeronautics. On September 30th, our Armstrong Flight Research Center marked its 75th year of innovation, milestones, and discoveries. In its early history, the center helped achieve the first supersonic flight. Today, Armstrong continues its groundbreaking aeronautics research, as well as work in space transportation and in many Earth and space science missions. Check out go.nasa.gov/Armstrong75 for more about Armstrong's 75th anniversary. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/Twan.